Good afternoon, everybody. We are today going to do a quick recap of the review for the Chapter 7 test. I'm going to run through the answers to these questions fairly quickly. If there are some that you have trouble with, you might want to rewind and watch a particular section a couple of times because, as I said, I am going through it fairly rapidly. Okay. First off, section 1 is about combining like terms and using that to solve simple equations. Okay? So if there is no equal sign, we are just going to take our like terms and we are going to combine them. For number 1, we have 5x plus 3x. That's going to equal 8x. I am done. For number 2, I look at my like terms. I see that I have 6p and minus p. Those are my like terms. Those together, 6p minus p, gives me 5p. In addition to this, I have a second term here, negative 6 minus 6. These are not like terms, so I can't do anything more than say 5p minus 6 is my answer. Number 3, we get a little bit tricky. We have the same variable, t squared here. The variable is t. But t and t squared are not like terms. To be a like term, you have to have the same variable raised to the same exponent. So 2t squared and 5t squared, the ones I underlined in red, those are like terms. This minus t here in green, not a like term. And then in addition to that, we have the plus 3 and the plus 4. Those are like terms. And what we're going to do is we're just going to combine the things that have the same color, our like terms. We're going to start with our variable that has the highest exponent, so 2t squared plus 5t squared. That's going to give me 7t squared. I then go to the next variable down, so t raised to the first power, or just t, so minus t. And finally, all the way at the end, we normally put our numbers, and we get plus 7. So this is my answer here. If you had something like this, 7t squared plus 7 minus t, this is technically correct, so you would not lose points for that, but the way we like it is what I have boxed in blue with the counting down from 2 to 1 to 0 as your exponent. Okay? So, we are going to move on from there. Alright, number 4. Again, we're still just combining like terms. Nothing really complicated about it. We look for our like terms. 4y, 2y, that's 1. 3x minus x, that's 2. Okay, first thing I'm going to do is I'm going to combine my x's. 3x minus x is 2x. Then I'm going to combine my y. 4y plus 2y is 6y. It is positive, so I put plus 6y. These are not like terms, so I have to be done. There's nothing else I can do. Number 5, once again, I look at my like terms. 4n, 8n, and then separately, 2m cubed minus 2m cubed. Okay? And the first thing I'm going to notice is this, I actually get lucky here because 2m cubed minus 2m cubed, those cancel out. They add up to 0. So I don't actually have an m cubed term in here. It's just 4n plus 8n. 12n is going to be my answer, and I am done. For number 6 and 7, we take the same idea that we've just been doing here, and we extend it to equations. Notice I now have an equal sign. This makes it an equation. Okay, so I have to be just a little bit careful with what I'm doing, but nothing really major changes here. First thing I notice is I have on one side of the equal sign like terms, 9y minus 5y. Let me take a second to caution you, because I've seen a lot of students try to do this. Do not do something like this. Plus 5y, plus 5y. Or, I'm sorry, here's what I've seen students doing. I see plus 5y, plus 5y. That crosses out. What do you know? I have 14y equals 8. This is 100% incorrect, wrong. you will get the wrong answer every single time. Because when we're doing something like this, what you're really trying to do is do the same operation to both sides of an equal sign. But look where your equal sign is right here. It's here. There is nothing being done over here. But look what you did. You did it twice on one side of an equal sign. So this is not correct. What you want to do is you want to keep in mind where your equal sign is. That's why I have drawn this red line right here, and the blue line, which will disappear in a second, right next to it. I'm drawing that so that you can keep in mind where my equal sign is, and when you're going to do something on both sides, you actually do something once on the left of this line and once on the right of this line. If, however, your like terms, as they are here, are actually both on the same side, then all we do is combine like terms. So I'm going to say 9y minus 5y is 4y. 4y equals 8. And then to solve that, divide by 4. Divide by 4. What do you know? Y equals 2. And I'm done. It's just that simple. Same thing over here. Number 7. I have 7x plus 2x. That's going to give me 9x on this side equals 45. To get x by itself here, I divide by 9. Divide by 9. X equals 5. And I'm done. So far, so good. Now we're moving on to section 2 from the chapter. Solving multi-step equations. Okay, first thing I notice, same thing. I've got like terms, but I've got some more stuff going on in addition to that now. So first thing I want to do, if possible, combine any like terms that are on the same side of an equal sign. So for this one, number 8, I get 8c plus 8 equals 32. And from here, it's just a two-step equation. Step 1, minus 8 minus 8. I'm going to get 24 equals 8c. And then step 2, divide by 8, divide by 8. C is equal to 24 divided by 8, which is 3. Okay. Number 9 and 10, pay close attention to if you hate fractions. Number 9 is our special case. Notice every single term, not just the ones with denominators, but every single term. Here's term 1, term 2, term 3. Every single term in the entire equation has a denominator, and it is the same denominator. So I can just cross those out. Okay? Pretend they're not there and rewrite the equation as if they never existed. 3x minus 2 equals 10. And then to solve this, it's a simple two-step equation now. Plus 2, plus 2, 3x equals 12. Divide by 3, divide by 3, x equals 4. Not too bad. You know what I'll do, though? I will make it look like a 4. That's all right. Divide by 3, divide by 3, x equals 4. All right, so that's number 9. Number 10, we cannot get quite so lucky because we do not have the same denominator each time. But what we can do is find our common denominators. And remember, the way we find our common denominator is we list out factors if we can't see it without doing this. Sorry, we list out multiples. 3, 6, 9, 12, 4, 8, 12, 12, 24. So we've listed out all of our multiples from our denominators, and we look for the lowest number that's in every list. And that turns out to be 12. Okay? So now that I have 12, what I am going to do is I'm going to multiply every term by 12 on both sides of my equal sign. And then I do my favorite thing in the whole world. I cross-cancel. 12 and 12, those are both going to give me 1s. 3 goes into 12 4 times, so the 3 becomes a 1, the 12 becomes a 4. And 4 goes into 12 3 times, so the 4 becomes a 1, the 12 becomes a 3. And now I just write what's left. I've got this 3 here times this t here, so I've got 3t. I've got 3t. I've got 4 times t as well, so plus 4t equals 7 times 1, which is just 7. Now I have an equation where I can simplify like terms here. 3t plus 4t, that's 7t. So 7t equals 7. And finally, I get t by itself by dividing by 7. Divide by 7, I get that t equals 1. And I am done. Okay. We've got a couple more of these to do. We do the same thing for number 11. We find our least common denominator. I've got 3, 6, and 2, so my least common denominator is going to be 6. I'm going to move this down just a bit, make it a tiny bit bigger, give myself a little bit more room to work. So 3, 6, and 2, my least common denominator is 6, so I multiply every term by 6. And look what I can do. This 6 and this 6 both become 1. This 6 becomes a 3. This becomes a 1, because 2 goes into 6 3 times. And 3 goes into 6 2 times, so the 3 becomes a 1, the 6 becomes a 2. And then I just make sure that I multiply everything together that I have, because, for instance, over here, I still have 2 times 4m. So I can't forget that. I have 8m minus 1 times m is just m, equals 7 times 3, which is 21. Okay? 8m minus m is 7m. So 7m equals 21. Now we have a simple one-step equation. Divide by 7. Divide by 7. M equals 3. I'm done. Finally, for number 12, same thing. I find my least common denominator. 4 and 5 have no common multiples until we get to 4 times 5, which is 20. So what I'm going to do is I'm going to multiply everything by 20. And do any cross-canceling that I can. 4 goes down to 1, 20 goes down to 5. 5 goes down to 1, 20 goes down to 4. Here there's no cross-canceling, it's just 11 times 20. Well, 11 times 20 is 220. And I get 5 times 3b is 15b, minus 4 times b is 4b. 15b minus 4b, most of the time, 15 minus 4 is 11, so 11b equals 220. And then to get b by itself, divide by 11. Divide by 11. 220 divided by 11, well, that makes b equal to 20. And we're done. We've done 2 sections now. Not a lot of difficulty here, and we've done a lot of practice on this. Okay? So moving on. Number 3. Now we are solving equations with variables on both sides, and I remind you that screwy things can happen. Okay? We don't like variables on both sides, so the first thing we're going to do is try to usually just get rid of the smaller one. So here it's the x, so subtract x from both sides. I get 3x plus 11 equals 2. And then what I'm going to do from there is I'm going to pause my video and talk to me. Okay, thank you for being patient, everybody. I helped Mr. Hale figure out what was wrong. It's just that he made a typo and he's not real bright. So anyway, we are in the middle of question 13. First thing I did is take away x from both sides. I get that 3x plus 11 equals 2. And then it is a simple 2-step equation from here. Minus 11, minus 11. I get 3x equals negative 9. And I divide by 3 to get x by itself, divide by 3, x equals -3, and I'm done. Yay. Okay, we move on to number 14. Q plus 5 equals 2q plus 7. Well, I see that I have variables on both sides, so I'm going to take q away from this one, take q away from this one. I see that 5 is equal to q plus 7. All right? Once I do that, I want q by itself, so I take away 7. I take away 7. And I see that 5 minus 7 is -2. That equals q. And I'm done. See how simple these are? Okay, number 15. I'm going to take my smaller coefficient variable term out. So minus 4n, minus 4n. 6n minus 4n is 2n, plus 21 equals 57. Two-step equation. Should be able to solve this in our sleep. Minus 21, minus 21. 36 equals 2n. Divide by 2. Divide by 2, n equals 18. I'm going to keep going. Okay. I'm going to give myself some more room. 2m plus 6 equals 2m minus 1. I'm going to take 2m from both sides, because I don't like variables on both sides. But here's where screwy starts happening. They both cross out. So look what I'm left with. 6 equals -1. Is 6 equal to -1? Of course it's not. So what this means is that this equation cannot possibly be satisfied. So what we say is there is no solution. That means that there is no value that I can put in for m that would make this true. No solution is our answer here. Number 17. I've got this thing I have to do first because 9w minus 2w, these are like terms on the same side of my equal sign. I must combine those first before I do anything else. 9w minus 2w, 7w, plus 8 equals 4w plus 38. Now I can do what I like to do and get variables to only one side. So minus 4w, minus 4w. I get 3w plus 8 equals 38. Two-step equation, minus 8, minus 8. 3w equals 30. Not too hard to see there that w is 10. Divide by 3, divide by 3. W equals 10. Yay. Once you've done enough of these, they just become so easy that you really don't have to do a lot of thinking to get them right. Number 18. Once again, we've got to combine some like terms before we can do anything else with this multi-step equation. So -4a minus 2a, that's -6a, plus 11 equals 6a minus 13. Let's see what we can do from here. Well, I'm going to take away the smaller one. The smaller one is -6a, so plus 6a to both sides. This one drops out. I've got 11 equals 12a minus 13. Two-step equation from here, plus 13, plus 13. 24 equals 12a. I sure hope almost everyone at this point can see the answer. Divide by 12, divide by 12. 2 equals a, or a equals 2. And we're good there. Number 19 is one that several people are going to hate. But there's nothing really all that complicated about this one because we know how to deal with the fractions. So what we want to do, I'm going to just give myself a little bit more room to work with this one. Okay? I can get the denominators to go away by just multiplying everything by the common denominator. Well, with 12, 4, and 3, the common denominator is 12, so I multiply everything by 12. And when I say everything, I mean every single term on both sides. All 4 of them. Then I will do any cross-canceling that's possible. 12 and 12 will both give me 1s. 12 and 4, the 12 becomes a 3, the 4 becomes a 1. 2y and 12. The 2y is not in the denominator, so I can't cancel anything there. And then the 3 and the 12. The 3 becomes a 1, the 4 becomes, or the 12 becomes a 4. Now I just multiply. I've got 7y minus 3 equals 24y minus 5 times 4 is 20. From here, it's a straightforward multi-step equation, minus 7y minus 7y. I've got negative 3 is equal to 24 minus 7 is 17y minus 20. I'm going to add 20 to both sides. Negative 3 plus 20 is 17. So 17 equals 17y. Well, that's convenient. Divide by 17 on both sides. And I get that 1 is equal to y, or y equals 1. And I'm done. I'm going on to section 4 for our final review questions. Systems of equations. Only thing more complicated about this is that they're a little bit more complicated. If I see that I have variables that are, or I have two equations that are both solved for the same variable, in number 20 they're both solved for y. I know what, and I want to know the solution, which means I want to know the point that both x's and y's are the same for both of these. Well, if I know that my y's are the same, then I know that these must be the same. So I write negative 3x plus 2 equals 4x minus 5. And then it's just this, an equation like I was solving in the previous slide. So what I do, I add 3x to both sides. Because negative 3 was smaller, I want to get rid of that one. So I have 2 equals 7x minus 5. Two-step equation from here. Plus 5, 7 equals 7x. Divide both sides by 7. And I get 1. Take a little bit more room. I get 1 is equal to x. And I am not done. The reason I'm not done is because I wanted the solution to a system of equations. I do not have the solution to a system of equations. I have what x equals. To find y, I go back to either of my original equations, whichever one looks easier, and that one looks easier to me, y equals 4x minus 5. I write it down, y equals 4x minus 5, and I plug in what I know x equals, which is 1. So y equals 4 times 1 minus 5, which means y equals 4 minus 5, which means y equals negative 1. Once I know that that is my y, I write my answer like this. X comma y, or 1 comma negative 1. And I am done. That is my answer. Okay. Number 21. I will probably need a little bit more room, so I'm going to shrink all of this stuff I just did down. Okay. And now I shrink this down. Boom, 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 boom. Okay, and I start with 21. Once again, same thing. My y's are already solved for. So if y equals y, that means that these two guys have to equal each other too. Okay? So I get that 5x minus 3 equals 2x plus 6. Minus 2x on both sides. 3x minus 3 equals 6. Simple two-step equation. Plus 3, 3x equals 9. Divide by 3. I I get x equals 3. Still not done, though, because I need to know what y equals. Well, I'm going to take the easier looking equation, which I guess is, they look about the same to me. I guess I'll use that one there. Y equals 2x plus 6. So I'll write it down here, y equals 2x plus 6. And I will substitute in what I just found out that x is equal to. So y equals 2 times 3 plus 6. Y equals 6 plus 6. Y equals 12. I write my answer like this. 3 comma 12. And I'm done. Number 22, same thing. These two guys have to be equal to each other. So what I'm going to write is that negative 2x plus 6 equals 3x minus 9. I will combine my like term, or I will get my variable to only one side, so I will add 2x to both sides. I get that 6 is equal to 5x minus 9. I will add 9 to both sides, trying to get x by itself. I have 15 equals 5x. I still don't have x by itself, so what I will do is I will divide both sides by 5. I get that 3 is equal to x. I am still not done, however, because I have to go back up, figure out which equation I will use. Once again, this one certainly looks easier to me. Y equals 3x minus 9. So to find y, we'll go down here, y equals 3x minus 9. And I will plug in what I know x equals. Y equals 3 times 3 minus 9. Y equals 9 minus 9. Y equals 0. That's pretty easy. And so my solution is then 3 comma 0. I'll write that right here, 3 comma 0. And that's my answer. Okay, we've got 3 more to do. And one little old world problem. Okay, so number 23. Here's where it starts getting a little bit different. I do not have these solved for a single variable, so that step needs to be done. What I want to do is I want to look for the easiest variable that I can find, and here it's the x's. The reason for that is they do not have a number in front of them, so that saves me a little bit of work later on. So what I want to do is solve each of these for x. Well, I'm going to take the first one here. X plus y equals 8. The way I will solve that for x is I will get rid of the y by subtracting y from both sides. Well, look what I have now. X equals 8 minus y. Okay? So that is going to be my new equation. Just want to break this up real quick, because I want to bring this guy clone this. Okay. I want to bring this guy up here and shrink it down, because this is what this equation turns into. Okay? So I get the first equation turns into this first one, and then I want to do it with the second one. I want to take the second equation and also solve it for y. X plus 3y equals 14. Okay? So I need to get rid of the 3y to get x by itself, so that's no big deal. Minus 3y, minus 3y. Look what happens. X equals 14 minus 3y. Keep in mind, this is not 11y or anything like that. 14 minus 3y, those are not like terms, so I have to keep it as 14 minus 3y. Okay? So I'm going to clone this one as well. Okay. clone. And I'm going to shrink it down and bring it up here, because the second equation turned into that. Okay. Now I have two equations. Here they are. I've got my x equals 8 minus y, and my x equals 14 minus 3y. Look at what we have. We have the same thing as we had before. If the x's are equal to each other, then these guys have to be equal to each other as well. So I write 8 minus y equals 14 minus 3y, and then I just solve this for y. I add y, I add y. That was not really what I wanted to do, was it? Sorry, I want to do the smaller one. And so what I want to do is add 3y. Add 3y, because negative 3y is smaller than negative y. I have 8 plus 2y equals 14. Take away 8 from both sides. I get that 2y is equal to 6. And then I divide both sides by 2. I get that y equals 3. Still not done, because I need to take one of my equations that I just started with here. Which one looks easier? I think this one looks easier. The x equals 8 minus y. So if x equals 8 minus y, if x equals 8 minus y, and I know y is 3, then I know that x equals 8 minus 3, so x equals 5. And then I just write down my answer in coordinate notation, 5, comma 3, and I'm done. A longer problem, certainly, but doable. Okay? Now I'm going to shrink all this stuff down because I will need the space. Okay, and now I'm going to do number 24. I once again want something solved. I want to solve for one variable, so I look for the easiest variable, the one that has a 1 in front of it. So what I know I'm going to do is both of these I'm going to try to solve for y. Okay? So the first one's easier. 2x plus y equals 12. I want to solve it for y, so I just take away 2x, and I get y equals 12 minus 2x. That's my first one. And then my second one here, 3x minus y equals 13. I need to solve this one for y as well. So first thing I do is I take away 3x from both sides. And look what happens. I have negative y equals 13 minus 3x. Well, what I want to do is I want to get y to be positive. So the way I get y to be positive when it starts out negative is I multiply it by negative 1. But if I multiply this by negative 1, I have to multiply the entire other side by negative 1. So look what happens. I get y equals negative 13 plus 3x, or 3x minus 13. Now that I have this, I've got a new system of equations that is solved for y, and I can go from there. And what I kind of want to do is I started with these two equations here. Now I have these two right here. I rewrote them to make this. So I kind of want to pretend that the equations in my black box here is the question that I'm being asked. I want to solve that system of equations. And so the way I do that, I just set the two sides equal to each other. The y's are equal to each other, so 12 minus 2x must equal negative 13 plus 3y. or plus 3x to find my solution. Okay, so I look for the smaller variable. It's the -2, so plus 2x, plus 2x. So I have 12 equals -13 plus 5x. To solve this, I will add 13 to both sides. I get that 25 is equal to 5x. And to solve for x, I just divide by 5. Divide by 5. I have that 5 is equal to x. Once again, though, you should know by now you're not done until you've solved for y as well. So I'm going to take the easier looking equation. I guess that's this one here. Y equals 12 minus 2x. Y equals 12 minus 2x. And so what I want to do is just plug in 5 for x, because I know that x equals 5. And so what I get is y equals 12 minus 10. So y equals 2. And once I know that y equals 2 and x equals 5, I can write my answer the way I like to, which is x comma y, or 5 comma 2 in this case. That's my answer. And at this point, we probably don't need any of this stuff, so I'm going to erase this. Just to give myself some more room, I will move over everything else. Okay. Now what I want to do is I want to take all of this. No, that's not what I wanted to do. Now what I want to do is I want to take all of this.
What you mean all of this?
Baby, he's doing.
And I want to move it over. So that I can answer my last question. Okay. Okay. And that last question is 4x minus 3y equals 33, and x equals -4y minus 25. I already have the x solved here, so what I want to do is on the other one, I want to solve for x as well. Okay? So I don't have to touch this one. This one's good for me. So all I'm looking at is the top one, 4x minus 3y equals 33. And so what I want to do is solve for x. So the first thing I need to do is get rid of the 3y.
You did it.
All right, sorry about that. We had a little bit of a disruption, so I'm going to start number 25 again, because I honestly don't remember where we were. Okay, so here's what's happening. We are going to take these two equations, and we need to solve them each for the same variable. And I notice, hey, I've already got the second one solved for x, so this one's done. The only one then I have to redo is this 4x minus 3y equals 33. So I want to solve this for x, 4x minus 3y equals 33. And so what I do is I first get rid of this 3y term by adding 3y to both sides. Once I do that, I rewrite my equation. I get 4x equals 33 plus 3y. Now, I still don't have x by itself, but I'm closer. I need to get the 4 out of the way, so I divide by 4. And then I have to divide everything over here by 4, and that's where it gets a little bit ugly. But we have x is equal to 33 over 4 plus 3/4 y. And that's what I can do. That's my equation solved for x. So now I have two equations solved for x. This one and the one that was originally solved for x. I'll write it down here. X equals -4y minus 25. And even though there are fractions and it looks a little bit screwier, I can set these equal to each other because I have both of them equal to x. If these two are equal to each other, then these two have to be equal to each other. So I have 33 over 4 plus 3/4 y is equal to negative 4y minus 25. Okay? Now that I have my equation that I want here, I can get rid of these fractions if I'd like by multiplying everything by the common denominator. Common denominator is just 4, so I multiply everything by 4. And here's what happens. On the left side, those are going to cancel out. They both give me 1s. These are going to cancel out. They both give me 1s. And on the right side, I'm just going to end up multiplying. So here's what it winds up being. I get 33 plus 3y equals negative 16y minus 100. Okay, so we've got some bigger numbers, but no big deal. What I'm going to do, I'm going to get rid of the smaller variable on both sides, which is negative 16, so I add 16y to both sides. That goes away. I have 33 plus 19y equals negative 100. Okay? Then it's pretty straightforward from here. This is a two-step equation, even though our numbers are a little bigger than normal. Okay? I subtract 33. I subtract 33. I get negative 133. I sure hope that's a multiple of 19, because if it's not, I'll be sad. Let's see, that, yeah, that is. So that is 7. 7 times 19 should give me 133. 7 times 19, 63. I'm doing it wrong. 19 times 7. 63. 7 times 1 is 7. 13, 133. Yeah. So we know that if I divide both sides by 19, divide that side by 19, negative 133 divided by 19 is negative 7. So y equals negative 7. I have y. I'm still not done, though. Okay? Because remember, we need to find what x is. So I go back to one of my equations. I'm going to take this one. This x equals negative 4y minus 25. Oh. X equals negative 4y minus 25. And I'm going to plug in what I know y equals. So x equals negative 4 times negative 7 minus 25. Negative 4 negative 4 times negative 7 is 28. So I have x equals 28 minus 25. That's pretty simple. X equals 3. And I'm done. I've got x equals 3, y equals negative 7. I write my answer in the way that I normally do, which is like this, x comma y, 3 comma negative 7. Call myself done. Say congratulations, me. I am done with all of those questions, and now I've just got this one question left. The sum of two numbers is 18. Their difference is 8. The numbers are x and y. Write a system of equations to describe their sum and their difference. This is something you haven't quite seen before, but it's not really that tough, because let's look at what we have here. The sum of two numbers is 18, and they're telling us that the numbers are x and y. Well, how do I write that the sum of two numbers? Well, it's just adding them. So I know that x plus y must equal 18. And then they give me one other piece of information. Their difference is 8. Difference just means subtract. So x minus y equals 8. What do you know? We have a system of equations. Fantastic. Now solve it to find out what these two numbers are. This is one of the things we can do with systems of equations like we've been talking about, is we can find missing information like this, where instead of having to guess through a whole bunch of different options before we find the right answer, we can get it right the first time, every time, by describing it like this. The sum of two numbers equals 18. That's x plus y equals 18. The difference of two numbers is 8. X minus y equals 8. And this will allow us to find our two numbers perfectly the first time. What I have to do now, for part B, I have to then solve this, which means I need to get both of them I need to get one variable isolated in each equation. And I look and I say, well, x has no coefficient here, no coefficient here. It means that the coefficient really is 1. And so that's going to be my easier one to solve for. So I'm going to first solve this one, x plus y equals 18. And I'm going to solve it for x, which means I subtract y from both sides. And I get that x equals 18 minus y. For the next one, we're going to do the same thing. I'm going to solve it for x. X minus y equals 8. I need to get this x by itself, so plus y. X is equal to 8 plus y. Now I've got two equations, and they're both solved for each other. They're both solved for x, rather. So x equals 18 minus y. X equals 8 plus y. And I can solve this fairly simply by just setting them equal to each other. So I get 18 minus y equals 8 plus y. Going to add y to both sides. I get 18 is equal to 8 plus 2y. Okay? And now this is a two-step equation. Do this in our sleep. Minus 8, 10 equals 2y, so y equals 5. Okay, so y equals 5. I still need to find x. I'll use the simpler equation. X equals 8 plus y. So x equals 8 plus 5. So x equals 13. And I just write my answer together the way I like to. X comma y, which is 13, comma 5. I am done. I have solved a word problem and I didn't even break a sweat. That's it for the video. Rewatch anything you need to. Good luck on the test tomorrow.